Hello everyone, good afternoon. So we are going to start electromagnetic field theory, 20 important questions. So first question is, which of the following vector represent magnetic flux density? Magnetic field intensity. So we can apply magnetic field intensity. So to check magnetic field intensity, what we will do? So first of all we can do del dot B is equal to 0. This is to check magnetic field. To check electric field, del cross E is equal to null vector, and to check potential, del square V is equal to 0. So this is valid for time varying and statics. This is valid for statics, and this is valid for source free medium. Which one? Source free medium. Okay. So we can go through that. First one is valid for time varying and statics, both cases. This one is valid for statics, and this one is valid for source free medium or charge free medium. Okay. Source free medium and charge free medium. So first question is regarding this one. So first option is A is equal to del dot A is equal to 0. So x component is differentiated with respect to x, y component is differentiated with respect to y, and z component is differentiated with respect to z. So del dot A is equal to, first one is differentiated with respect to x, 0, with respect to y 4xz, so 4xz, and with respect to z 0, so it will be 4xz. It is not equal to 0, so we can say that it is not valid. Second option, B option, this one is A, del dot A is equal to 0. So del dot A is equal to, so with respect to x 0, with respect to y 0, and with respect to z 0. So it will be 0. So B option is correct. C option, with respect to x del dot A, sin x differentiation is cos x. Sin x differentiation is cos x. Sin x differentiation is cos x. Cos e to the power cos y, e to the power x. Cos y differentiation is minus sin y. And z 4zq. So it is not equal to 0. Last option is del dot A is equal to, so del dot A is equal to, with respect to x 0, with respect to y 0, and with respect to z 0. So answer is 0. With respect to x 0, with respect to y 0, with respect to z 0. So our option is B and D. Our option is B and D. Any doubt you may ask. Okay. So this is our first option with respect to x, y, and z. With respect to x, y, and z. So our answer is A and D. Next option is, second question is very good question. It is a very good question. What they have asked in this question, the uniform plane wave is normally incident on a pair of dielectric slab This is a very good question. In the exam they may ask this type of question. Consider reflection and transmission to up to order only. Percentage of transmitted electric field with respect to incident electric field is. So transmitted electric field they are asking with respect to incident electric field. First one has 1 1, second one has 1 4, third one has 1 2.25, and fourth one has 1 1. So we are going to discuss this one. So there is a two block. There is a two block. This type of question may be asked in GATE exam. So you can solve by yourself also. So first one has mu 1 1, mu r is equal to 1, and epsilon r is equal to 1 4 1, mu r is equal to 1, epsilon r is equal to 4, mu r is equal to 1, epsilon r is equal to 2.25, and last one is mu r is equal to 1, epsilon r is equal to 1. So we have to decide the value. It is a very good question. So here we have a E1, then we have E1, then it will be reflected, transmitted. So you will get E2. Yes, sir. Then this one will again transmitted. So you will get E3. And then it will be transmitted. So you will get E4. So second one is E2. So first one, here gamma 1 and tau 1. Then we have gamma 2 and tau 2. Then we have gamma 3 and tau 3. So first of all I will calculate gamma 1. For gamma 1, T is 1, epsilon T is 4, epsilon I is 1. So under root epsilon I minus under root epsilon T divided by under root epsilon I plus under root epsilon T. So what is incident? 1. What is transmitted? 4. So 1 minus 2, 1 plus 2. So it will be minus 1 by 3. So tau 1 will be 1 plus gamma 1. So it will be 1 minus 1 by 3, 2 by 3. Yes, sir. Then we are going to start calculate gamma 2. Then we are trying to calculate gamma 2. Gamma 2 is, incident is for gamma 2, incident is 4 and transmitted is 2.25. So incident is 4, under root 4, 2, 1.5, 2 and 1.5. So it will be 0.5, 1 by 7. So tau 2 is equal to 1 plus gamma 2. 1 plus gamma 2 is 8 by 7. Then gamma 3. For gamma 3 incident 2.25, transmitted 1. So 1 minus 1.5 and 1 plus 1.5. So it will be minus 1 by 5. So tau 3 is equal to 1 plus gamma 3. So it will be 4 by 5. Then we have E1. So transmitted is E2. E2 by E1 is tau 1. Then E3 by E2 is tau 2. And E4 by E1 is, E3 is tau 3. So I will multiply 1, 2 and 3. I will multiply 1, 2 and 3. What we will get? I will multiply 1, 2 and 3. What we will get? So multiply 1, 2 and 3. So multiply 1, 2 and 3. So E2, E2 will be cancelled out. E3, E3 will be cancelled out. E4 by E1. Tau 1, tau 2, tau 3. Tau 1 is 2 by 3. Tau 2 is 8 by 7. And tau 3 is 4 by 5. So how much in percentage? You can calculate how much in percentage. It's a very good question. How much in percentage? So 2 by 3 into 8 by 7 into 4 by 5. Somewhere I did wrong. Anywhere I did wrong. So for this incident is 4. So 1 minus 2, 1 plus 2. 1 minus 2, 1 plus 2. Okay. 2 minus 1.5, 2 plus 1.5. So it will be 0.5 divided by 3.57. 1.5 minus 1. So I did wrong here. 1.5 minus 1. So 1.5 minus 1, 1.5 plus 1. So it will be 1 by 5. So it will be 1 plus 1 by 5, 6 by 5. 6 by 5. So answer will be 8 into 6 into 2 divided by 35 divided by 3. 0.9142. 0.9142. So in percentage it will be 91.42% is reflected. Any doubt you may ask? This is a very good question. Any doubt you may ask? This is a very good question. Very good question. So what we have to do? First of all, we have to understand incident minus transmitted. 1 minus 2, 1 plus 2. So 1 minus 2, 1 plus 2. 4 minus 2.2, 1.5, 2 minus 1.5. So 2 minus 1.5, 2 plus 1.5. 2.5 1.5 minus 1, 1.5 plus 1. So you will calculate like this. It's a very good question. This type of question will be due in GATE exam, and this type of question will be asked in GATE exam because this is a very good question. In MTech, this type of mathematics you will do, but in higher level mathematics, okay. A uniform plane wave with electric field is something incident on a dielectric slab z greater than equal to 1, mu r is equal to something 2.1 and 2.56, then the reflected electric field will be. So they are asking reflected electric field. Okay. So they are asking the reflected electric field. Electric field has how many components? Electric field has only one component. The electric field has only one component. So what we will do? This is a S polarization or P polarization. You have to decide first. So this is oblique incidence question. This is a question from oblique incidence. Okay. All questions are good and tough. I will say all questions are good and tough. Okay. So in which plane they are traveling? ZX plane they are traveling. So I will do first ZX plane. I will draw ZX plane. This one is Z, this one is X. We have 4 types of wave, incident wave. First incident wave is in third quadrant. Second incident wave is in so this is our incident wave. Okay. So this wave is traveling in plus Z and minus Y direction. So if you ask, first one is traveling in which direction? First one is traveling in which direction? I'll mark by different pen. So it is traveling in plus Z and minus X direction. If I will ask, second one is traveling in which direction? So second one is going in this direction and in this direction. Then I will ask, third one is traveling in which direction? So third one is traveling in this direction and this direction. Then I will ask, fourth one is traveling in which direction? So fourth one is traveling in this direction. So it is traveling in this and this direction. So I will ask, this one is traveling in plus Z and minus X direction, going downward minus X direction and plus Z direction. This one minus Z and minus X direction. This one plus X and plus Z direction. This one plus X and minus Z direction. So I will ask, first one is traveling in which direction? Plus Z and minus X. So minus X and plus Z. Second one is traveling in plus X and plus Z. So plus X and plus Z direction. Third one is traveling in minus Z and minus X. So minus X and minus Z direction. Fourth one is traveling in plus X and minus Z. So plus X and minus Z direction. We have a wave in plus X and minus Z. So plus X and plus Z direction we have. So I will say which one is correct? This one no. This one yes. This one no. This one no. So or which one is correct? Third one is correct. This one is correct. This one is a very beautiful question from oblique incident. Then which one is, we have a boundary? We have a boundary Z greater than equal to 0. So Z greater than equal to 0, Z less than equal to 0. So this one is a boundary and this one is normal. So if boundary is given Z greater than equal to 0, so Z axis is normal. If it is given X greater than equal to 0, so X axis will be normal. If it is given Y greater than equal to 0, so Y axis will be normal. So normal will be decided by boundary. The normal will be decided by boundary. Propagation will decide the plane. If it is traveling in XZ plane, so it will be XZ. If it is XY, so XY plane. If it is YZ, so YZ plane. So plane will be decided by this wave and boundary will decide the normal. So this is the two things we have to understand. So boundary will decide the normal and wave will decide the plane. Which plane is good? Correct. So which one is normal? Z axis is normal. This one is normal. So we have theta I. Why it is normal? Because Z greater than equal to 0, dielectric, whose mu r is, mu t is 1 and epsilon t is 2.56. Similarly, Z less than equal to 0, we have mu t is 1, mu I is 1 and epsilon I is 1. Then we have reflected wave. So reflected wave direction is which direction? This one is plus X and plus Z direction. Reflected wave has in this direction and in this direction. So reflected wave is traveling in minus Z and plus X direction. plus x and minus z direction. This one is traveling in plus x and plus z direction. Then we have, so propagation direction we have calculated. Propagation direction we have calculated. So propagation is, reflected wave is plus x and minus z. So electric field is ER is equal to gamma E into 18 into cos omega t. Which one is changing? Plus x and minus z. So plus x minus 4x, and z is changing, so plus 3z ay cap. So minus 4x plus 3z, minus 4x plus 3z. So minus 4x plus 3z, minus 4x plus 3z, minus 4x plus 3z, minus 4x minus 3z. Yani this one is wrong. This one is wrong. Then we have second is 8.73. So it will be minus 8.73 or plus 8.73. So we have to calculate gamma E. So second we have to calculate gamma E. Electric field has how many components? Electric field has one component. If electric field has one component, then what will happen? Electric field has one component, then it is perpendicular polarization. Then it is perpendicular polarization. Okay. Then it is perpendicular polarization. Okay. So I am going to tell you for perpendicular polarization, because electric field will be in this direction, outward direction. Electric field EI. In this direction, electric field ER. So outward direction, perpendicular to the plane. Perpendicular to the plane, it will be outward direction. Okay. So for perpendicular direction, gamma E will be under root epsilon I cos theta I and under root epsilon T cos theta T and under root epsilon I cos theta I and under root epsilon T cos theta T. So we don't know the cos theta also. We don't know the theta I and theta T. So this is gamma perpendicular. So for perpendicular polarization, we have to calculate epsilon I and epsilon T first of all. So what will be the component? What will be the component? So beta will have component, cos component beta x and sin component beta z. So beta has component beta I sin theta I and cos component beta z beta I cos theta I. You can see beta I cos theta I z component, beta I sin theta I x component. X component is given how much? X component is given 4 and z component is given 3. So x component is 4, z component is 3. So tan theta is equal to 4 by 3. So theta is equal to 53 degree. Sin theta is equal to, it will be how much? It will be 5 by 3. 4 by 5. 4 by 5. Then under root epsilon I sin theta I under root epsilon T sin theta T, because mu I and mu T is 1. Mu I and mu T is 1. So under root epsilon I is 1. Sin theta is epsilon T is 2.56 sin theta T. So you will get sin theta T is equal to under root of 1 sin theta is 4 by 5 and of 2.56 1.6, so it will be 0.4, so 1 by 2, so it will be 0.5. Sin theta t we have calculated. Then I will calculate gamma perpendicular. Under root epsilon I cos theta, under root epsilon t cos theta t, and under root epsilon I cos theta I, and under root epsilon t cos theta t. Under root epsilon I is 1, cos theta is 3 by 5, under root epsilon t is 1.6, cos theta t is 1 minus 1 by 4 root 3 by 2. Under root epsilon I is 1 and 3 by 5 and 1.6 and root 3 by 2. So I will calculate the value. No, it is for electronics branch. 1 minute. So 3 by 5, 3 divided by 5, 0.6. So 1.8 into root 3, 1.38, 0.6, 0.6 minus answer divided by 0.6 plus 0.4. It will be approximately minus 0.4. So ER will be 0.4 into how much? 18. So it will be 7.12. Gamma E into minus 4x plus 3z. Cos theta is equal to 3 by 5. Okay, 7.2 is the correct answer. So 7.2 is the correct answer. A by cap. So our answer is 7.2 minus times is, so A is the correct answer. So answer is A. Okay. Next question. Next question is a uniform plane wave in free space normally incident on a large block of a material epsilon r4 mu r3 sigma is 0 occupies z greater than equal to 0. If the incident plane electric field is something, then the reflected magnetic field is. So incident electric field is given. They are asking reflected magnetic field. So first of all, I will calculate HI. HI is equal to 1 by eta I into API cross EI. So this is the formula for electric field magnetic field conversion. So first of all, I will calculate incident plane normally on a large block of material. So incident is from free space. So eta I is equal to 120 pi mu I upon epsilon I. Mu I is 1, epsilon I is 1. So mu I and epsilon I is 1, so 120 pi. Propagation direction is API. Propagation direction is given minus z, so plus z direction. So HI will be 30 divided by 120 pi, 1 by 4 pi, and cos omega t minus beta z, cos omega t minus z, and z cross y is minus x. Z cross y is minus z cross y is minus x. So it will be minus x. So normal incidence HI we have calculated. So we have first of all calculated eta I, then we have calculated PI, and then we have calculated HI. Then what we will do? I will calculate gamma I. Gamma E. Then I will calculate gamma E. Okay. So for gamma E, what we will do? Epsilon I is equal to 1, mu I is equal to 1, epsilon T is equal to 12, and mu T is equal to 12. 3. Then eta I is equal to 120 pi, eta T is equal to 3 divided by 4, so it will be 60 pi. Then gamma E is equal to eta T minus eta I, eta T plus eta I. So it will be 60 divided by 180, 1 by 3. Then gamma H is equal to minus 1 by 3. Gamma H is equal to minus times of gamma E, 1 by 3. So we have calculated gamma H. So HR is equal to, HI is given, yes sir, 1 by 4 pi cos omega t minus z ay cap minus x minus x cap. So HR will be multiply with gamma H. So gamma H 1 by 3 So 1 by 12 pi. Then cos omega t. Omega is asking the question. No, it is in the form of omega t. So cos omega t. Reflected wave will be in opposite direction. So plus z and minus ax cap. So this is the value. In reflected, the propagation direction is only changing. So multiply with gamma h and change the direction of propagation. So we have solved many questions like this. So 1 by 12 in milliampere. So 1000 by 12 pi. 1000 by 12 pi. 1000 divided by 12 pi. It will be 26.52. 26.52 minus x cap minus x plus x. So both are in plus. So this one is B is the correct answer. Minus x cap. So A is the correct. C is the correct answer. Okay. This is the question. Next question. Next question is a non-magnetic transmission line reflection coefficient of parallel polarization is oblique incident is are correct. So they are asking transmission coefficient and reflection coefficient. In GATE exam, they will directly ask this question. In GATE exam, they will directly ask this question because this is question from SEDICO. So in GATE exam, they will directly ask this question. So you have to prepare for that. Okay. You have to prepare for that. So what we will do? Parallel polarization. So what we have first of all, under root epsilon I sin theta I under root epsilon t sin theta t. Then we have under root epsilon I upon epsilon, under root epsilon I upon epsilon is equal to sin theta t upon sin. First equation. Then for parallel polarization, gamma is gamma for parallel polarization. For parallel polarization, gamma is under root epsilon I sec theta I under root epsilon sec theta t under root epsilon I. So first of all, I will take under root epsilon. First of all, I will take under root epsilon t common. So it will be under root epsilon I epsilon t under root epsilon I epsilon t. Sec theta is 1 by cos theta and sec theta t is 1 by cos theta. Sec theta is 1 by cos theta I and sec theta is 1 by cos theta. So you will put the value of epsilon I and epsilon t ratio. You will put the value of epsilon I and epsilon t ratio. So what you will get? What you will get? You will get under root epsilon I sin theta t upon sin theta I and into cos theta t into cos theta I. Similarly, the plus form. So sin theta t cos theta t cos theta I sin theta I divided by sin theta t cos theta t. So it will be sin 2 theta t multiply with 2 in all side, multiply with So what you will get? You will get sine 2 theta t, sine 2 theta I, sine 2 theta t, sine 2 theta I. Then we have sine 2 theta t, sine 2 theta I. Then we have I will solve sine A minus sine B and sine A plus sine B. So sine A minus sine B, sine C minus sine D, and sine C plus sine D. What is the value? It will be 2 sine A minus sine C plus sine D. C is equal to A plus B and D is equal to A minus B. So what we have? 2 cos A sine B and 2 cos A sine B means 2 cos A is C plus D divided by 2 and sine C minus D divided by 2 cos sine C plus D divided by 2 and cos C minus D divided. So what we have, gamma is equal to 2 sine theta I. So C is 2 theta t, 2 theta I. So 2 theta t plus 2 theta I, theta t plus theta I, and cos theta t plus theta I, sine theta t minus theta I. Similarly, 2 sine theta t plus theta I and cos theta t minus theta I. So we have 2 and 2 cancel out. So sine upon cos is tan, sine upon cos is tan. So sine upon cos is tan, sine upon cos is tan. So tan theta t minus theta I upon tan theta t plus theta I. So this is a very good ratio. So tan theta t plus theta I and theta t minus theta I. Answer is B. Answer is theta I minus theta t, theta I plus theta I. Answer is B. Then we have transmission coefficient they are asking. Then they are asking transmission coefficient. Gamma is equal to 2 sine 2 sine 2 theta t sine 2 theta I sine 2 theta t and sine 2 theta I. So 1 plus gamma is equal to, if I will add this one, so this one will be added, this one will be cancelled. So 2 sine 2 theta t and sine 2 theta t plus sine 2 theta I. So I will break this value. So what will happen? Tau is equal to 1 plus gamma e cos theta I upon cos theta. So put the value. So 2 sine theta t cos theta t divided by sine 2 theta t cos sine 2 theta I into cos theta I cos theta t. So this one will be cancelled out. So we have transmission coefficient formula 4. This one is 4. 2 into 2, 4. 4 sin theta t cos theta and sin 2 theta t plus sin 2 theta I. So tau is 4 sin 2 theta t 2 theta I. Okay, and the denominator will be also there. So I will solve this one also. It will be 4 sin 2 theta t cos theta I divided by sin A sin B. So 2 sin theta t plus theta I and cos theta t minus theta I. So 2 and 2 will be cancel out. So 2 sin theta t cos theta I sin theta t plus theta I and cos theta t plus theta I. This is the formula. So it is a very good question. In the GATE exam, they may ask. The GATE exam, they may ask. So cos theta I sin theta t sin theta cos theta I is the correct answer. So these are the two questions. So these two questions will be, they may ask reflection coefficient. So you have to solve reflection coefficient, put the value, simple question. But take the formula, put the value, ratio, solve this ratio, solve using trigonometric function, you will get the answer. Simple. Then after you have to put the value and solve, you will get the answer. So trigonometry plus formula, it is a question. It is a question from trigonometry plus formula. So this one is for perpendicular polarization. This one is for parallel polarization. And now they are asking for perpendicular. Now they are asking for perpendicular. So it is also a good question. So perpendicular polarization I have to solve. So similarly, same thing, epsilon I sin theta I, epsilon t sin theta t. Same formula, same. So under root epsilon I, epsilon t sin theta t on sin theta. Similarly, gamma perpendicular under root epsilon cos theta I and under root epsilon t cos theta t. I will take the ratio. I will take the ratio. Under root epsilon I upon epsilon t cos theta I cos theta t under root epsilon I epsilon. put the value of ratio. So you will put the value of ratio sin theta t upon sin theta I, cos theta I, and cos theta. So the ratio will be sin theta t, cos theta I, cos theta t, sin theta I. Sin A cos B, cos A sin B, sin A minus B. So sin theta t minus theta I upon sin theta t plus theta I. In the form of sin it is. So in the form of sin, the gamma will be in the form of sin. So answer is sin theta t minus theta I and theta t plus theta. Now we have to calculate tau. Now we have to calculate. So tau is equal to 1 plus gamma I. So tau is equal to 1 plus gamma I. So when you add, you will get sin theta t will be added. It will be subtracted. So it will be 2 sin theta t cos theta I and divided by the, so it will be sin theta t plus theta I. So 2 sin theta t cos theta I and sin theta t plus theta I is the correct. The very good question. Perpendicular. Now we have next question. Pi and Pt are incident and transmitted power respectively. The prism is right angle isosceles triangle. This is also from SEDICU question. This question was asked in MTech first mid sem. So this question may be asked in GATE exam also, because this is a basic type question. Incident and transmitted. The prism is right angle isosceles triangle having permittivity 2.25. The ratio of transmitted upon incident power. So transmitted upon incident power. So it is a very good question. So this is a isosceles triangle. What will happen with this one? The light is incident this side. A light is incident from this side. And it will be normal incidence, will be normally incident. And at this corner, it will not will incident on which direction? Obliquely incident. And then after, it will be reflected, transmitted. Huh? So we have the question. This is isosceles triangle. So this is 45 degree and this is 45 degree. Why? Isosceles right angle triangle it is given. Right angle isosceles triangle. Right angle isosceles. Isosceles means 45 degree, 45 degree. This is our angle theta I. This is our angle theta I. So this is 90 degree. So this will be 45 degree. So theta I will be 45 degree. So in this case, theta I will be 45. And sine theta C is equal to epsilon I upon epsilon. Epsilon T upon epsilon. So epsilon T is 1. Epsilon T is 1. Incident. So this one is transmitted. This one is incident. Incident is 2.25. So it will be 1 by 1.5. So theta C will be 2 by 3. So sine theta C will be 2 divided by 3. 41.81 degree. So what will happen? Since theta C is greater than theta I is greater than theta C. So TIR. Total internal reflection. So what will happen? This one is E1. Transmitted is E2. Totally reflected is E2. And transmitted is E3. So here total internal reflection. Sir, how total internal reflection will happen? Because incident is 45 degree isosceles right angle triangle and sine theta C is incident upon transmitted. So our incident is isosceles triangle, prism, and transmitted is air. So transmitted is air 1 and this one is prism, so 2.25. So we have calculated sine theta C. So theta C we have calculated. So incident angle is greater than theta C, so it will be total internal reflection. First point is this one. Then we have what we have. Then we will calculate the transmission coefficient and reflection coefficient. Then we will calculate the transmission coefficient and reflection coefficient. So first here we will calculate transmission coefficient gamma 1 and tau 1. Then here we will calculate gamma 2 and tau 2. So gamma 2 and tau 2. This one is normal incidence. This one is also normal. So E1 to E2 normal incidence, E2 to E3 normal incidence. So first of all I will calculate gamma 1. Gamma 1 is equal to under root epsilon I minus under root epsilon divided by under root epsilon I plus under root epsilon. Epsilon I is how much? Incident is air 1. Then we have a prism under root 2.25, 1.5 and incident is air and 1.5. So it will be minus 1 by 5. Minus 1 by 5, that means 1 is equal to 1 plus gamma 1. So it will be 4 by 5. Similarly gamma 2, so incident is glass, transmitted is air. So 1.5 minus 1, 1.5 plus 1. So it will be 1 by 5. So tau 2 will be 1 plus gamma 2. So it will be 6 by 5. Then we were going to calculate electric field. So E2 by E1 is tau 1 and E3 by E2 is tau 2. So what we will do? We will multiply. So E3 by E1 is tau 1 into tau 2. Tau 1 is 4 by 5. Tau 2 is 6 by 5. So we will calculate the value in percentage. In percentage you can calculate. It's a very good question. So 4 divided by 5, 4 divided by 5 and into 0.8 in 1.2 into 0.6, 0.8. It will be 0.96. 0.96, that means how much it will be? 96%. So answer will be 96, or the ratio will be 24 by 25.96. Can calculate like this. It is a very good question. All questions are tough in this class. Transmission line has first voltage minimum occur at a distance of 2 meter from the load. The distance between first voltage minima and second voltage minima is 8 meter. VSWR is 4 and characteristic impedance is 60. They are asking the value of load impedance. Very easy. They are asking the value of load impedance. It is very easy. So X minimum is given. How much? 2 meter. Lambda by 2 is given. How much? 8 meter. Lambda is equal to 16 meter. VSWR is equal to 4. Characteristic impedance is equal to 60 ohm. Okay. Then we are going to calculate. What we are going to calculate? We are going to calculate load impedance. I think load impedance they are asking. Yes, sir. So what we will do? We will calculate X minimum. X minimum is 2n plus 1 pi plus theta gamma into lambda divided by 4 pi. This is our X minimum. X is equal to, X minimum is equal to 2n plus 1 pi, theta gamma we don't know, lambda 16 divided by 4 pi will be 8 pi 16. So pi by 2. Pi by 2, 2n plus 1 pi plus theta gamma. So theta gamma is equal to pi by 2 minus 2n plus 1 pi. N is equal to 0. Theta gamma is equal to, n is equal to 0. What you will get? You will get pi. So minus pi by 2. Minus pi by 2. N is equal to 1. N is equal to 1. What we have? Theta gamma is equal to, so 1 minus 3 pi by 2 minus 3 pi. So 3 pi is 6. So minus 5 pi. N is equal to minus 1. Theta gamma is equal to minus 1. So it will be pi by 2. So 5 pi by 2. 3 pi by 2. So what we have? Theta gamma is equal to minus pi by 2. Then magnitude of gamma L is equal to VSWR minus 1, VSWR plus 1. VSWR minus 1 is 3 divided by 5. Gamma L is equal to mod gamma L e to the power j theta gamma. How much mod gamma L is? 3 by 5 and theta gamma is e to the power minus j pi by 2. So it will be minus j 0.6. Minus j 0.6. Then gamma L we have calculated. So ZL is equal to Z0 into 1 plus gamma L and 1 minus gamma L. Z0 is 60 ohm. Gamma L is 0.6. So j plus 0.6 divided by 1 minus j plus 0.6. First one is minus, second one is plus. Minus plus. So what you will get? You will get 10, 5 minus 3. So 60 5 minus J3 divided by 5 plus J3. Multiply with conjugate 60, 5 minus J3, 5 plus J3 and 5 minus J3 divided by 5 minus J3. So it will be 60 and 5 25 minus J square minus 9 and 15 minus 15 minus J30 and divided by 25 plus 9. So it will be 35. So 60 divided by 35 and 25 minus 9 10 minus J30. So it will be 60 divided by 25 into 16, so 38.4 minus J 2.4 into 30 plus 70. Let us check the calculation. Minima. BSWR is 4. If I will take n is equal to 0, it will be minus pi by 2. If I will take n is equal to minus 1, so minus 1 plus 1, okay? Minus pi, minus minus plus 3 pi by 2. And n is equal to 1, 3 pi by 2, 3, 3 2 is 6, minus 5 pi by 2. $60, 1 minus J 0.6, 5 plus J3, 10 plus J6, 10 minus J6, 5 plus J3, 25 plus 9, 27.4, 27.43 and 60 into 30 divided by 35, 51.42. So 27. So approximate answer will be C. Approximate answer will be C. Okay, divide by 34 now. Thank you. Thank you. Yes. Yes. It is divided by 34. So 60 into 16 divided by 34, 28.23, and 60 into 30 divided by 34, 52.94. Our answer will be. So this is a very good question. Mathematically, it is very. Okay. What do you want to know, Suraj Patel? Suraj Singh Bhattacharya ji. Okay. On a transmission line, voltage maxima is given and last voltage maxima is 40. VSWR characteristic impedance transmission line is 3.6, 150. Reflection coefficient they are asking. Simple question. Can solve by simple question. First is lambda by 2 is. So transmission line voltage maximas are 120 centimeter apart. So lambda is 240 centimeter. And the X max is 40 centimeter. So X max is 40 centimeter. VSWR is 3.6 and Z0 is 150 ohm. So first of all, I will calculate mod gamma L. VSWR minus 1, VSWR plus 1. So VSWR minus 1, VSWR plus 1. 3.6 minus 1, 3.6 plus 1. How much it will be? 3.6 minus 1, 3.6 plus 1. So 3.6 minus 1 divided by 4.6. It will be 0.565. 0.565. So 0.565 you can take magnitude and you will get the answer. So take the magnitude and you will get the answer. So mod gamma L. Okay. Then theta gamma we have to calculate. Max is equal to 2n pi plus theta gamma into divided by 4 pi into lambda. X max is 40 centimeter into 4 pi. Lambda is 240 and 2n pi plus theta. So what is theta gamma? Theta gamma is 16 divided by 240, 160 divided by 240. So it will be 2 by 3, 2 pi by 3, 2 pi by 3 minus 2n pi. So n is equal to minus 1. Theta gamma is equal to 6 minus. So 3 दूनी का 6, 6. So minus 2. Minus 4 pi by 3. N is equal to 0. Theta gamma is equal to 2 pi by 3. Yes. Then you will calculate theta gamma L. Gamma L is equal to mod gamma L e to the power j theta. Cos 2 pi by 3 is cos 2 pi by 3 is cos pi 2 pi by 3. So mod gamma L. Cos 2 pi by 3 is cos pi by 3 1 by 2. And sin pi by 3 it is sin So minus 1 by 2 and minus root 3 by 2 plus root 3 by 2. So we'll put mod gamma L is equal to e to the power j 2 pi by 3. So mod gamma L is 2.6 divided by 4.6 divided by 2, 0.282, 0.2826 minus j plus plus into root 3. So 0.283 plus j 0.549. 0.283 and 0.49. Answer is okay. A transmission line of length 1000 meter is terminated by a load located at point A in Smith chart as shown in the figure. The line operates at 1.5 megahertz. The difference between the number of voltage maxima and voltage minima. So they are asking voltage maxima and voltage minima. So first of all, theta gamma is given. How much? 130 degree. So theta gamma is 130 degree. So divided by 180 into pi. So it will be 13 pi by 18. 13 pi by 18. Then after theta gamma we have calculated. Length is given. How much? 1000 meter. Frequency is given. How much? 1.5 megahertz. 1.5 megahertz. So lambda is equal to C0 upon F. C0 is equal to 3 into 10 to the power 8 and F is 1.5 megahertz 10 to the power 6. So it will be 200 meter. So lambda we have calculated, length we have calculated. We have to calculate voltage of maxima and minima difference. So X max is equal to 2n pi plus theta gamma into lambda divided by 4 pi. X max should lie between 0 to L. So X max is equal to 0, 2n pi plus theta gamma into lambda divided by 4 pi into L. 0, 2n pi plus theta gamma, lambda is 200 and 4 pi and length is 1000 meter. So 2 5 times. So it will be theta gamma is 0. So minus theta gamma 2n pi and is equal to 20 pi plus theta gamma minus theta gamma. 20 pi minus theta. So minus theta gamma divided by 2 pi 10 minus theta gamma divided by, so its value will be theta gamma 13 divided by 18 divided by 2. It will be minus 0.36 and 10 minus 0.36. So n should lie between 0, 1, 2, 3 up to 9. So number of maxima is 10. Number of maxima is 10. Number of maxima is 10. It's very easy. Then we have minima. So minima is equal to 2n plus 1 pi plus theta gamma into lambda divided by 4 pi. So 2n plus 1 plus theta gamma into lambda divided by 4 pi. So 2n plus 1 pi plus theta gamma is equal to 20 pi. So it will be minus pi, it will be go this side, minus theta gamma and minus theta gamma divided by pi 2n plus 1 is equal to 20. (13 by 18) (360 minus 30) 347 by 80. So it will be minus 13 minus 13 minus 18 minus 31 by 18. (347 minus 18 329 by 18. Minus 31 by 18 divided by 2 minus 0.86. 329 divided by 18 divided by 2 9.138. So n is starting from 0, 1, 2, 3 up to 9. So number of minima is also equal to 10. Number of minima is equal to 10. So number of maxima 10, number of minima 10, it will be 0. Difference is 0. Difference is how much? So number of maxima 10, number of minima 10, will be difference will be 0. A quarter wave transmission line of characteristic impedance 200 ohm terminated by a load impedance 400 ohm. If the voltage at load end is 30 volt, voltage at sending end they are asking. Easy question. This type of question I have done in the class. ZL is equal to ZL is greater than Z0. So here voltage maxima, V max, I mean, and here at lambda by 4 voltage minima, V min, and I ZL greater than Z0. So we have ZL greater than Z0. So we have VSWR is equal to ZL by Z0. 400 by 200. It will be 2. Vmax by Vmin is equal to 2. Vmax is given. At load it is given 30 volt. At source it is not given. So Vmin is equal to 15 volt. The answer is 15 volt. If they may ask current also, So I mean is equal to Vmax by ZL. Vmax by Z. Voltage is Vmax, current is minimum, Vmax by ZL. Vmax is 30 and power is ZL is 400. So 3 by 40. So you can calculate Imax also. So Imax upon Imin is equal to SWR, and SWR is equal to 2. So we can calculate Imax. Imax is 2 times of Imin, 3 by 20 ampere. Then you can calculate Zmax. Z0 into VSWR. So 200 into 2, 400 ohm. And you can calculate Zmin. Z0 upon VSWR. So it will be 200 by 2. It will be 100 ohm. You can calculate Imax, Imin, Zmax, Zmin, everything you can calculate. So this is the answer. So Vmax, Vmin we have calculated, Imax, Imin we have calculated, and Zmax, Zmin we have calculated. Z0 is given, delivered is 100 giga load is itna, the current value is 20 ampere. So power we know that, we know the voltage. So what they are asking, VSWR they are asking. So voltage at load, power at load is 20 kilowatt, current at load is 20 ampere. So VL is equal to power at load upon IL. Power at load 20,000 divided by 20. It will be 1000 volt. Then ZL is equal to VL by IL. 1000 upon 20. So it will be 50 ohm. Then ZL we have calculated, VSWR is equal to Z0 by ZL. Why? Z0 is greater. 150 divided by 50. It will be 3. This is very easy question. Just you have to go through that. Because ZL is less than Z0, so Z0 by ZL. Then we have a quarter wave transformer characteristic impedance is 50 ohm, has been matched with transmission line of characteristic impedance Z0 to a load 80 ohm. Okay. Quarter wave transformer is given. Transmission line characteristic impedance is not given. Load impedance is given. So we have a transmission line. Then we have a quarter wave transformer. This is also a good question. Then we have a quarter wave transformer. Quarter wave transformer. This one is ZL. This one is Z0 1, and this one is Z. So what is Zin? So Z0 is equal to under root Z0 1, and Z0 1 is equal to, this is ZL1. So under root Z0 into ZL, and you can derive also. So input impedance Z0 1 square upon ZL1 is equal to Z0. So Z0 1 is equal to under root ZL1 into Z0. ZL1 into Z0. Next case is, it is replaced by Z02. It is replaced by Z02. So it is Z02 and it is ZL2. Z02 and this one is ZL2. So we have Z02 is equal to under root ZL2 into Z0. So we have what we have? We have Z01 under root ZL1 into Z0, and we have Z02 under root ZL2 into Z0. So we have Z02 upon Z01 under root ZL2 upon ZL1. Z02 we don't know. Z01 50, ZL2 80, and ZL1, so ZL2 60, ZL1 80. So what will be the value? 60 divided by 80 under root answer into 50. It will be 43.3 ohm. This is our. So what will happen? This transmission line impedance is same. Load is changing, Z0 is changing. So here Z0 is ZL into Z0, ZL into Z. And in this case, ZL is changing, Z0 is changing. So we have 43.3. C is the correct answer. Then a lossless transmission has ZG is given, characteristic impedance is given, generator voltage and load impedance they are asking. Transmission line, assume that 600 meter and phase velocity is equal to C. So length is given, phase velocity is given, time is given, and 0, t. So it is source voltage is given. So which voltage is known? Source voltage is known. So we have to calculate the value. So at t is equal to 0, at t is equal to 0, V is equal to V0, Vs is equal to V, Vs is equal to V, and at t is equal to 2t, Vs is equal to V0 plus V1, V0 plus V1 plus V0 is 8 and 5 volt. This one is 8 volt and this one is 5 volt. Then we have V0. V0 is equal to Vg into Z0 divided by Zg plus Z0. So V0 is 8, Vg we don't know, and ZL and Z0. Zg is 60, Z0 is 50. So Z0 is 50, Zg is 60. So 60 plus 50. So what we have? We will calculate the value of Vg. So Vg is equal to 6 880 divided by 50. how much it will be? Will be 880 divided by 50. 17.6. This one is wrong. This one is wrong. Then we have load impedance. They are asking. They are asking load impedance. So V0 plus V1 plus V2 is equal to 5. V0 plus gamma L V0 plus gamma L gamma G V0 is equal to 1 plus gamma L and gamma L gamma G is equal to 5 divided by 8. 5 divided by gamma G is equal to gamma G is equal to gamma G is equal to ZG minus Z0 ZG plus ZG is 60 minus 50 is 60 plus will be 10 by 1 by 11. So 1 gamma L and gamma L by 11 by 8. So gamma L by 11. So 12 gamma L by 11 is equal to 3 by 8 minus 3 by 8. So gamma L is equal to minus 3 into 11 divided by 12 into 8. So gamma L we have calculated. Gamma L is equal to minus 11 divided by 32. So ZL is equal to Z0 1 plus gamma L 1 minus gamma L Z0 1 plus gamma L 32 minus 11 32 plus 11 into 15. So 21 divided by 43. 21 divided by 43 into 50 into 50. So 21 divided by 43 into 50. 24 point. $24.42. Okay. So this is a good question. So it will be 24.42. शॉर्टकट है सर इसका? शॉर्टकट कुछ नहीं है, शॉर्टकट ऐसा कुछ इसी टाइप का गोट में क्वेश्चन पूछता है, थोड़ा ऑप्शन सही बना नहीं पाया है, इसमें ZL का ऑप्शन चेंज कर दे। आज ऑप्शन बहुत रॉन्ग है। आंसर है सी। ठीक है, सी आंसर है। Then after, transmission line has a characteristic impedance 300 ohm, terminated at a load having minima and maxima found in the line. If the load is replaced by open circuit, the minima is shifted by lambda by 4 away from previous value. The VSW of line is 3. The load impedance will be. So case 1 is ZL is equal to open circuit infinite. ZL is equal to infinite. So at x is equal to 0, what we have? X is equal to 0, x is equal to lambda by 4, x is equal to lambda by 4, x is equal to lambda by 2, and x is equal to 3 lambda by 4. So here it will be voltage maximum, voltage minimum, voltage maximum, and voltage minimum. In second case, what we will have? In second case, it is replaced by some unknown load. It is replaced by some unknown load. So second case is it is replaced by some unknown load. We don't know. So here what will happen? Lambda by 4. The minima is shifted by lambda by 4 from the previous value. So lambda by 4 shifting. So here voltage minimum. So it will be shifted at here. So at load, voltage minimum. At lambda by 4, voltage maximum. So voltage minimum at load. Voltage minimum at load. This is the point which you have to understand. X is equal to lambda by 4. V min at lambda by 2. 3 lambda by 4. Lambda by 2. And V max at 3 lambda by 4. So it is shifted by lambda by 4. So V minima is shifted by lambda by 4. So V minimum will be shift to V maximum. V maximum will shift to V minimum. Will be shift to V. Lambda by 4. Okay. So ZL is unknown. So V minimum at load. V minimum at load. V minimum at load, that means short circuit or open circuit. V minimum at load. And VSWR is equal to 4, 3. So ZL is less than Z0. ZL is less than Z0. So VSWR is equal to 3. Z0 by ZL. So ZL is equal to Z0 by 3. Z0 is given, I think, how much? 300 ohm. 300 divided by, it will be 100 ohm. It will be 100 ohm. Next, a transmission line is said to be distortionless. LG is equal to RC. A parallel plate waveguide TE3 mode is 0.55 times of velocity of light in freeze. The waveguide has been filled with a material having dielectric constant 9. The frequency of the wave is 1 GHz. the guided wavelength of TM2 mode is? Very good question. So first of all, I will ask point, what is the value? So Vp bar is equal to 0.55 times of C naught. Vp is equal to C naught upon under root mu bar epsilon. So C naught by 3 epsilon r is, and Vp bar is equal to Vp upon cos theta. So cos theta is equal to Vp upon Vp bar. So Vp upon Vp bar. So cos theta is equal to 1 by 0.55 into 3. How much it will be? 0.6 or 0.8? So 0.55 into 0.6. So sin theta is equal to 0.8. So FC is equal to sin F into sin theta. Sin theta is equal to FC upon F. So FC is equal to 0.8 into F. FC is equal to how much? FC is equal to Vp by 2D, MVP by 2D. MVP by 2D. M is 3. So 3 Vp by 2. FC is equal to MVP by 2D. So MVP by 2D is equal to, M is how much? Here M is equal to 3. So 3 Vp by 2D. So 3 Vp by 2D is equal to 0.8 F. So Vp by D is equal to 1.6 F by 3. This is our. Then Vp by D we have calculated. Then we will go for the TM2 mode. So for TM2 mode, what we will have? For TM2 mode, FC is equal to MVP by 2D. M is equal to Vp by D. FC we have calculated. Then sin theta is equal to FC upon F. Vp by D is equal to 1.6 F upon 3F. 1.6 F upon 3. So FF will be cancelled out, 1.6. So cos theta you can calculate, under root 1 minus sin square theta. So 1.6 divided by 3 square 1 minus answer under root answer 0.85. Then lambda is equal to Vp upon F. Vp is equal to C naught by 3 upon F. C naught 3 into 10 to the power 8. F 1 gigahertz. So it will be 0.1 meter. Then lambda G is equal to lambda upon, have lambda upon cos theta. So 0.1 divided by answer 0.118582. It will be 0.12 meter. RCTV, yes, LG RCTV. This is a very good question. Very good question. This type of question in waveguide they have asked. because they will ask not direct question. So Vp bar is given, Vp is given, so you have to calculate cos theta. From that cos theta you have to calculate sin theta. From sin theta you can calculate Fc. From Fc you can calculate Vp by d ratio, or you can calculate the value d. So I will calculate, I will not give the calculate the point, because that will give some error. So that's why I will calculate in terms of variable only. So 3 Vp upon d, m is 3, so 3 Vp upon 2d, so we can calculate Vp upon d. Then Vp upon d is utilized, yeah. So sin theta will calculate, then from sin theta you can calculate cos theta. From f and Vp you can calculate the value of lambda, and in that case lambda and cos theta you know, then you can calculate lambda g. It's a very good question. Then we have a rectangular waveguide of copper has 7 cm and 4 cm. The waveguide is filled of material of dielectric constant. The tangent loss is itna, the mode it will propagate at 3 GHz. So frequency is given, we have to calculate the value. So first of all I will calculate Fc. Fc Mn. Fc Mn is equal to Vp by 2. Vp by 2 under root m by a whole square n by b whole square. So Vp is equal to 3 into 10 to the power 8 2 epsilon r is equal to root 3 m by a is 7 cm 10 raised to the power minus 2 whole square, and n is 4 cm 4 into 10 raised to the power minus 2 whole square. So it will be minus 10. Yes sir. So it will be minus 10. So 3 divided by root 3. So root 3 divided by 2. Root 3 divided by 2. And 4 and 7. So it will be 28. So it will be 0.31 10 raised to the power 9 gigahertz into 16 m square plus 49 n square gigahertz. 16 m square plus 49 n square gigahertz. So Fc should be less than F should be greater than Fc. F should be greater than. So F is 3 gigahertz. F is how much? We have calculated root 3 divided by 2 divided by 28 to 10. So 0.31 into 10 raised to the power 9 under root for 28 16 m square plus 49 n. 16 m square plus 49 n square. So it will be cancel out. So 16 m square plus 49 n square is less than 3 divided by 31.31 square 93.65. So A option is m is equal to 1. Yes, m is equal to 1, n is equal to 0. Satisfy? Yes. Second, we have to calculate the value. M is equal to 1, n is equal to 1. 49 plus 16. 49 plus 16. It will be 65. Yes, it is satisfying. 0, 1, 49 is satisfying. 2 1, so 16, 4 into 16, 64 plus 49, it will be 1 1 by 3. No, it is not satisfying. 2 2, not satisfying. 2 0, so 32, it is satisfying. So I will check the value each and every case. I will check for each and every case. So here it is M, here it is N, here it is T10, TM11 or T11, T01 and TM22, T21 and T20. First is T is 10, TE01, TE20, TE11, TM11, T12, TE21, TM22. So you have to calculate the value. Here M is equal to 1, N is equal to 0, 0, 1, 2, 0. So 2, 0 and 1, 1, 2, 1 and 2, 2. Here 16 M square plus 49 N square. How much it will be? 16 M square, 16. 49 N square, 49. So 4 4 is 16, 64 and 1 1, so 16 plus 49, it will be 5, 63 and 2 1 and 1 2, 64 plus 49, 64 plus 49, 1 1 3 and 64 plus 49 into 4 plus 49 plus 16 into 4, it will be 260. So this is greater than, less than 93 point, less than 93.65. This one is less than 93.65, less than 93.65, less than 93.65, greater than 93.6, and this one is also greater than 93. So which one is possible? Less than is possible. Less than is possible, greater than is not possible. So T10 possible. So 1011 is possible. 0111 is possible. And 20 is possible. So this is the answer. So this type of question may be asked in GATE exam. If I have done somewhere wrong calculation, do not panic for that. So if I have done somewhere a calculation wrong, don't panic. So I will check once again also. 30 divided by 2 divided by root 3 divided by 28.31. 3 divided by 0.31 square. Then a rectangular waveguide A is given, B is given, dominant mode is given, 6 GHz is given, peak field is given, and they are asking the value. So first of all, A is greater than B. A is greater than B. So A is greater than B, so dominant mode is T10 mode. So FC10 is 3 by 2. Epsilon and mu r is 1. So C0 by 2a. C0 is 3 into 10 raised to power 8. And A is 2 into 10, 4 into 10 raised to power minus 2. So it will be 30 divided by 8 gigahertz. Will be 3.75 gigahertz. It will be 3.75 gigahertz. So 30 divided by 8, 3.75 gigahertz. Then FC we have calculated sin theta is equal to FC upon F. Frequency I think given 6 gigahertz. So 3.75 divided by, it will be 0.625 gigahertz. And 0.265 cos theta is equal to 1 minus answer square under root answer. Point 625 0.78. So cos theta you have calculated. So eta t em 120 pi eta t mod eta Tm upon cos theta. Eta Tm is how much? 120 pi. Cos theta is 0.78. So 120 pi divided by 0.78. 483.32. 483.32. So we have calculated eta Tm. Then we will calculate P average. P average is E0 square upon 4 eta T 10. So E0 is how much? E0 is 50 volt. Whole square divided by 4. Eta T is how much? 483. 483. So it is in watt per meter. Then W is equal to power handling is equal to power handling they are asking. Yes, power. So power will be equal to P average into AB. So 50 whole square 4 into 483.3. A is equal to 4 centimeter 10 raised to power minus. So 50 divided by 50 into 50 divided by 4 divided by 483.32 into 12 divided by 1, 2, 3 is 4. So in milliwatt will be, in milliwatt it will be 1.55 milliwatt. So process is important. Which one is important? Process. First of all, you have to find out dominant mode. Then you have to find out the cutoff frequency. Then you have to find out sin theta. Sin theta, after that cos theta, eta T mode. So eta T you will calculate. So P average you can calculate. This formula is important. So if it is T01 or T1 mode, T0N and TM0 mode, P average is equal to, power is equal to, you can remember this formula, E0 square upon 4 eta T. And for TMN mode, power is equal to E0 square upon 8 eta T So always try to remember here 4 eta t and here 8 eta t. You can calculate. Then we have a transmitter produce a maximum field of certain direction. Electric field is given. Input impedance of this lossless transmission 50. The maximum value of effective aperture area they are asking maximum value of effective aperture. So electric field is equal to 10 I naught e to the power minus j beta r 10 I naught divided by r e to the power minus j volt per meter. So you can first of all calculate 10 I naught divided by r e to the power j omega t minus. So real part of electric field will be 10 I naught divided by r cos omega t minus beta r. So P average is equal to E naught square upon 2 eta. E naught is 10 I naught square. 10 I naught by r whole square divided by 2 eta divided by 2. So it will be how much? 100 divided by 2, 50. So 50 I naught square divided by eta into r square. Then P average you will calculate it. So u theta phi is equal to r into P average, r square into P average. So 50 I naught square, 50 I naught square divided by so u theta phi you have calculated. Then W naught is equal to integration of u theta phi sin theta d theta d phi. Sin theta d theta d phi. Sin theta d theta d phi. So how much it will be? It will be 50 I naught square upon eta sin theta d theta d phi. Sin theta is 0 to pi and d theta d phi is pi. So 4 pi 200 pi I naught square upon eta. Then W naught you have calculated. W naught is equal to I RMS square in RR. That is I naught square in RR divided by 2 into R. So 200 pi I naught square 120 pi I naught square RR divided by. So I naught will be cancelled. So RR will be equal to pi. So 400 divided by 120. 400 divided by. So 4, 3, 10 by 3 ohm. So efficiency is equal to directivity is equal to 4 pi into u theta phi divided by w naught. So 4 pi into u theta phi maximum value. How much it has maximum value? So u theta phi maximum value is u theta maximum phi maximum value is 10. U theta phi maximum value is how much? It will be 50 I naught square upon eta. Same. 50 I naught square upon 4 pi. So 50 I naught square upon eta. And W naught is 200 pi I naught square. So it will be, so directivity will be, then efficiency will be ER upon ER plus ER. Then efficiency, 1 minute. Sorry for that. This one I have done wrong. So W naught is given, yes. RR is given. RR or input impedance is how much? 50 ohm. How much it is given? 50 ohm. So 50 ohm is given. So we can calculate W naught. W naught is I naught square to 50 divided by 2. So 25 I naught square. Then U theta phi is equal to, sir, 50 I naught square upon eta. So 50 I naught square, eta is 120 pi. So 0 0 will be cancelled out. 5 I naught square upon 12 pi. Then u theta phi maximum is u theta phi maximum is equal to 5 I naught square upon 2. Then directivity is equal to 4 pi into 5 I naught square upon 12 pi divided by 25 pi. 25 I naught square. I naught will be cancelled. 5 pi will be cancelled. And it will be 1 by 15. So directivity is 1 by 15. Then we have effective aperture area. Lambda square by 4 pi into directivity. Lambda is 4 pi and directivity is 1 by 15. You can calculate 1 by 15 60 pi meter square. So this is a very good question. Next we have 4 isotropic antenna, n is equal to 4, pi by 2 distance having phase current, in phase current, lambda by 2 distance, not pi by 2, lambda by 2 distance having in phase current. The approximate radiation pattern is, so approximate radiation pattern they are asking. Simple question. It is a very simple question. What we have to do? First we have to find out psi. First we have to find psi is equal to beta d cos theta plus alpha. Beta is 2 pi by lambda. Lambda by 2 cos theta plus alpha is 0. So it will be pi cos theta plus pi cos theta. Then we have n is equal to 2. So E is equal to E naught sin psi by 2 and psi by 2 sin psi by 2. N is how much? N is equal to 4. So 4 divided by 2 E naught and then after n sin 2 pi cos theta divided by sin pi by 2 cos theta. Then I will check theta is equal to 0, 90, 0, 90, 180, 270. That will give the value. So at theta is equal to 0, E is equal to how much? So theta is equal to 0, cos 0, 1, cos 0, 1. So cos 2 pi, sin 2 pi, 0, sin pi by 2, 1. So sin 2 pi is 0, sin pi by 2 is 1. It will be sin 2 pi is 0, sin pi by 2 is 1. So it will be 0. Theta at 90 degree, cos 90 degree, sin 90, sin 0, cos 90 degree is 0, cos 90 degree is 0, so 0. So sin 0 upon sin 0, so it will be E. So it will be 4 E naught. If you apply the limit, you will get maxima. So 4 E naught you will get. I will tell you how it is 4 after 2 minutes. Then 180 degree, cos 180 is -1, so minus sin 2 pi is 0, and this one is 1. So cos 180 is -1 minus 1, so it will be 0, and 270 is 0, so electric field is equal to 4 E0. So minima, minima, maxima. So this one is maxima. First one is maxima. So this one is maxima. This one is maxima. This one is maxima. This one is maxima. This one maxima, 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 maxima. No. This one is maxima, maxima, null, maxima, null. This one is null, maxima, null, maxima. So D option is. So maxima, null, maxima, you can calculate and you will get the. Okay. How sin 2 phi theta is something. So sin 2 pi cos theta on sin pi by 2 cos theta. So sin 2 pi cos theta and divided by 2 pi cos theta and 2 pi cos theta, so 4 into pi by 2 cos theta upon sin pi by 2 cos theta. Limit alpha tends to 0, sin alpha upon alpha 1. Similarly, so if you apply limit, cos theta tends to 0, so it will be, so if you apply limit here, cos theta tends to 0, so you will get, this one will become 1, this one will become 1, so it will be 4, will be 4. So this is our 4 answer. Last, the field pattern is f theta is given. They are asking directivity. This type of question may be asked in GATE exam. So f theta is equal to is given. So first of all, calculate W naught. Integration of f theta with respect to sin theta d theta d phi. So it will be cos to the power 4 theta sin theta d theta and d phi, 0 to 2 pi and 0 to pi by 2, 0 1, so it will be 1 x to power 4 1 by 5 and this one is 2 pi by 5, 2 pi by 5. Then we have directivity, 4 pi into u theta phi upon W naught. This one is the maximum value. So 4 pi u theta phi maximum value is 1 and W naught is 2 pi by 3 5. So it will be 10. In dB it will be in dB. So directivity in dB is equal to 10 log 10 will be 10 dB. Sin alpha upon alpha. This one is how you become all. Okay. Limit alpha tends to sin theta upon theta is equal to. So limit cos theta tends to 0. Sin theta sin 2 pi cos theta upon sin pi by 2 cos theta. So what I will do? I will divide and I will multiply. So limit cos theta tends to 0. Sin 2 pi cos theta divided by 2 pi cos theta into 2 pi cos theta divided by sin pi by 2 cos theta. Then we have this one is, so I will apply separate limit. I will apply separate limit. So limit cos theta tends to 0. Cos theta tends to 0. Sin 2 pi cos theta upon 2 pi cos theta and limit. Here I will apply separate limit. So 2 pi I will write 4 into pi by 2. So 4 limit cos theta tends to 0. Pi by 2 cos theta upon sin pi by 2 cos. So I will assume this one is a alpha 1 and this one is a alpha 2. 4 I will take outside. So 4 limit alpha 1 tends to sin alpha 1 upon alpha 1 and limit alpha 2 tends to 0. Alpha 2 upon sin alpha 2. So what I have done? I have taken this one as a alpha 2 and this one as a alpha 1. So if cos theta tends to 0, alpha 1 tends to 0. If cos theta tends to 0, alpha 2 tends to 0. So sin theta upon theta limit is 1. Sin theta upon theta limit is 1. So it will be 4. Understood? I think you understood. So sin theta upon theta 1. So it will be 4. Thank you for today class. Homework, nothing. You can do yourself. Thank you.